Jeffrey, delivery!
Hey, Mom.
Hi,
Dr.
Dr.
Jeff's
Jeff's
mom.
mom.
Ooh, did you bring us lunch?
I'm not sure what it is. I was cleaning out the garage and I found this box with your name on it. Do you still want it?
Wow, this must be 20 years old.
If it is lunch, I'm definitely not taking the first bite.
There could be treasure in there.
Or priceless antiques.
Or your baby clothes?
Or a robot companion. What? I get lonely sometimes.
Let's find out. Awesome. This is my Matter Science Kit. 3 experiments all related to the concept of matter.
But the bottles are all old and the labels have fallen off.
How will we know which material is which?
We can figure out what's in each bottle through the properties of matter. I'm Dr. Jeff Inneker, and today we'll explore the science behind the properties of matter. With Dr. Jeff. Welcome to Labracazam, where we make science make sense.
So what did you mean when you said that there were 3 science experiments related to matter?
Yeah, what's matter?
Nothing. What's the matter with you? Ha 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 ha. Ha 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 ha.
Matter is anything that has weight and takes up space.
Like this table, this pen, this robot.
I have a name, thank you.
So just about everything we can see or touch is matter.
Yes, and also things we can't see, like air, which has weight and it takes up space. Here, I'll show you. This balloon has air in it. This one does not. When we put the balloons on opposite ends of the seesaw, we see that the balloon with air in it drops.
It's heavier because it has matter in it.
So what isn't matter?
Things like ideas, energy, peace, even love.
I love you.
So wait, are you saying all of those concepts don't matter?
I can explain. Let's break it down. When scientists use the word matter, they're talking about solids, liquids, and gases. In order to do the 3 experiments in my Matter Matters kit, first we have to figure out which substance is in each bottle.
Part 1, solids. Take the sodium metal and drop it into the water, then run.
Solid. Now that's my kind of science.
For this experiment, we're wearing our goggles and our gloves to protect our hands and our eyes. One of these solids is sodium metal and the other is iron.
How do we know which is which?
I know one of the properties of iron is that it's magnetic. Sodium is not magnetic. It should be as simple as seeing which one sticks to the magnet. So that means this one is iron and this one is sodium.
Now that we know which one is sodium, let's perform the experiment. Don't try this at home. All right, Bert, I'm gonna need your help.
You bet. Anything in the name of science.
Take this piece of sodium metal and on the count of 3, drop it into the dish of water over there behind the safety shield.
All righty.
You'll be next to the dish while the rest of us stand over here.
Sounds good.
On 3, Bert.
I just love helping people.
1, 2, 3. Fire in the hole!
What?
Let's move on to gas.
Bert.
Pardon me.
Place sulfur hexafluoride gas in a fish tank and float an aluminum foil boat on top. What?
One of these gas canisters is sulfur hexafluoride. The other is helium. But we don't know which is which.
Let's test them.
I know that helium is what they use to make party balloons float.
That's right, Izzy. Helium is a gas that's less dense than air, so it rises up. How something rises or sinks is related to a property of matter called density. For example, this rock sinks in water, so we say it's more dense than water. This piece of wood floats, so we say it's less dense than water.
We can do the same thing with the gases by putting them in balloons. Helium is less dense than air, so it should float. And sulfur hexafluoride is more dense, so it should sink.
Let's fill these two balloons with the gases and compare their density. Three, two, one.
The pink balloon's more dense, so it must be the sulfur hexafluoride.
Great. Let's put some sulfur hexafluoride into the tank over here.
Whoa!
So what happens if sulfur hexafluoride gets in the boat?
Sulfur hexafluoride is heavier than air, so pouring it into our little boat makes it heavy enough to sink. And now it's time to discover why liquids matter.
Slowly place a piece of styrofoam into a cup of acetone.
Well, we have two clear liquids, so one of them must be the acetone.
And two lonely labels, acetone and water.
We can distinguish the two liquids through a property of matter called solubility. It measures how well one thing dissolves into another.
Right, like for example, how well salt dissolves in water. When salt and water mix, we call it salt water.
Oh, you are so smart.
Salt, on the other hand, does not dissolve in acetone. You can see that the salt dissolved in this liquid, but not in this one. That makes this one the acetone.
Now let's put the styrofoam into the acetone.
Okay. Whoa, how'd that happen?
Styrofoam is only 2% plastic, but 98% air. So the acetone softens the plastic and releases all the air. Once all the air is gone, all we're left with is a little bit of soft plastic.
All matter has properties: hard, soft, shiny, not shiny. But my favorite kind of matter is slimy matter. Yep, slime is matter and it has properties. And I'm about to show you how to make your own slime at home. Today, I asked my friend Charlotte to help me out. She is a true slime expert. Hi, Charlotte.
Hi, Zoe.
So what makes you a slime expert?
Well, I have one very important qualification. I think slime is awesome.
That's good enough for me. Let's get started. All you need to make your own slime is water, washable glue, and borax powder.
In a bowl, add half a cup of water and half a cup of washable glue.
In another bowl, add 1 teaspoon of borax powder to 1/2 cup of water. Stir it up and then add the borax water to the glue water.
I'm gonna add some blue food coloring. Stir that until it looks like this. Labracazam!
Classic slime. Now let's test its properties.
It sinks, so it's more dense than water.
And it's not soluble.
Check this one out.
This slime is magnetic.
I added iron powder to it.
That's so cool. Thanks for helping me out, Charlotte.
Leverkazam, Zoe.
To find out why the properties of matter matter, let's go to some real-world science. This grill is powered by the burning of propane gas. We use propane because of its properties. It's easier to compress inside of tanks compared to other similar gases. This pot is made of metal. If the handle were made of metal too, it would be too hot to touch. The plastic handle works so well because of its properties. It doesn't conduct heat as well as metal does. This is a knife and fork I made out of some Swiss cheese, and as you can see, it's rather ineffective. Most reusable utensils are made of stainless steel because of its properties. It's strong and it doesn't rust like iron does.
Now, let's review. Matter is a substance that has weight and takes up space. Matter can be identified through its properties like magnetism, density, or solubility. Engineers need to know the properties of matter so they can use the right materials for the job. Thanks for bringing this kit into the lab, Mom.
Of course, my dear. I love seeing you guys here.
I love you too.
What?
Nothing. I'm Bert.
I'm Dr. Jeff.
I'm Izzy.
I'm Zoe.
Join us next time on Labracazam. And remember,
Always question, always wonder.